All right, good afternoon, 8th grade. Glad you're back. This is Mr. Hale here, and we're going to keep going on our Chapter 14 lesson about temperature and thermal energy. Today, we're going to talk about heat transfer, conduction, convection, and radiation. So, let's go down there. Now, first thing about understanding this whole thing is what is thermal energy? Thermal energy, once again, is that motion of molecules, the kinetic energy of moving molecules. Okay? So, a molecule that has no energy got to get its energy from somewhere. So if I'm not moving, the only way to get me to move is to have something collide into me to get me moving. So we have to understand this basic idea. Heat system, a heat transfer, always goes from hot to cold. The hot objects, the objects that have the energy, transfer their energy to the objects that do not. So a cold object, that means the molecules are moving slow, speed up because the hot objects, which have the energy, transfer some of their energy over to the cold objects. Big point. Heat transfer is a one-way system from hot to cold. Always hot to cold. Now let's go down to our idea about heat transfer. How do we transfer heat from one object to the next? We have three ways of transferring our heat from one object to the next. You have conduction, convection, and radiation. Conduction is the heat transfer, heat transfer of direct contact. You have to be in physical contact to transfer the heat from one object to the next. Must be in physical contact. Convection is the heat transfer from differences in densities. When things heat up, remember when you're watching boiling water, the water at the bottom of the pot starts to heat up and you can actually see it move. Next time you try to boil water, look at it. You'll see bubbles moving up. The water is actually making little cycles, little circles. Heats up, goes to the surface, cools down, sinks back down. That is a convection cycle, and thus is transferring heat because the differences in density force it to move. The last one is called radiation. Radiation, you don't need anything to do it. The other two, you actually need molecules to interact. Molecules have got to be there to take one energy to the next. In radiation, you don't. The sun is 92 million miles away. There are no molecules, or virtually no molecules, between here and the sun. Go out during the summer day, you get a suntan, a sunburn, because of that. It's still moving, and you can get energy directly from that. So, heat transfer from atoms. Here, let's talk really quick about conduction. Give you a chance if you want to write down some notes for this. Heat is transferred from atoms that are touching. It is not carried by liquid or gas. You walk on a high sidewalk with your bare feet get hot. The heat is moving from the atoms of the sidewalk to your feet. Okay, that's conduction. Here's convection. Okay, see in the center, you have that red thing. That's your heat source at the very bottom. The water in the middle heats up, gets hot. When the water heats up and it gets hot, it expands because the molecules are moving faster. They take up less space. They got to spread out because they're moving faster. Just like in Bernoulli's principle, the molecules move faster. They got to spread out, thus becoming less dense. Thus, they rise to the surface. They hit the surface and they start to cool down. And as they cool down, they start to sink. As they sink to the bottom, they start to heat up again, creating this little circle here called a convection circle. Okay, where the water is constantly cycling through. It is mixing the water, thus a convection current. Okay, these are the two easiest ones to stop when you're trying to stop it. This last one is the hardest, radiation. Heat transfer by flow of electromagnetic radiation, energy waves. Okay, like heat felt from a campfire. You can feel the heat, but you don't see it. Radiation is the only type of heat transfer that can happen in a vacuum of space. That means no molecules are needed for this to happen. Okay, heat transfer is through the waves as it's moving on. Now, to reiterate, heat transfer is always from hot to cold. Always hot to cold. Now, there are some things called conductors and insulators. A conductor is something that works really well at conducting heat, and an insulator doesn't. This is something you can try if you want to, one of Mr. Hale's tries. Go home, take a match, put it under a frying pan. Take another match, put it under a piece of 2x4. Normally a 2x4 won't light on fire. Leave it there for 10 seconds. Which one would you much rather put on your face, the frying pan or the 2x4? Most of you guys are going to say the 2x4 because the 2x4 is not going to heat up as fast. Well, wood is a insulator and absorbs heat without changing temperature as much. Conductors, like pieces of metal, do a really good job of taking the energy and transferring that energy along and conducts it. Okay, now, starting our next lesson, we're going to talk about this thing called specific heat, and we're going to actually use this equation, Q equals mc delta T, and we're going to use them that. You're going to need, for our next lesson, you're going to need a calculator, if you want. Okay, some pens and pencils to write, or paper and pen to write some of the stuff down, because we're actually going to do some lessons on how to calculate this information and how much energy is there. So I hope you guys had fun. If you need to, rewind the video, watch it a few times. Don't forget, we talked about conductors and insulators. We talked about heat transfer, and we talked about the three ways of transferring heat: conduction, convection, and radiation. So if you have any questions, make sure you reach out to me. This is KD2.